Okay, in this video I'm going to continue to talk about the final exam review. So this will be the part 2 of the final exam review. So I'll go over the remaining questions and talk about the solutions. Okay, so in the previous video I talked about the solution for the first 10 questions. So I'm going to start with question number 11 for this review. Okay, start with question number 11. Okay, so the question number 11 talks about a relationship among a number of theorems. 3 theorems I mentioned in class. One is a Green theorem. Okay, and the second one is called Stokes. Should be Stokes theorem. And last one is the divergence theorem. Divergence theorem sometimes is also called Gauss theorem. Gauss theorem. Okay. So that's the same. Okay. So this question talks about the relationships, like what does Green theorem do? So the Green theorem actually is a way to rewrite. So it is to rewrite the double integral into line integral, or vice versa. You can say you can run the line integral into the double integral. And Stokes' theorem is to rewrite surface integral into line integral, or the vice versa, opposite, or write the line integral into the surface integral. That's the same thing. And divergence theorem or Gauss theorem is to rewrite triple integral into surface integral. Okay, so that's what is the question 11 is asking for. So try to find the relationship between the different integrals for the three theorems. Okay, this question number 11 is quite straightforward. Okay, let's go to the question number 12. Question number 12 is about the meaning of surface integral with a function which is 1. Okay, so it says, hey, let S to be, okay, let S be the surface of object. Okay, so the question is, what is the physical meaning? Physical meaning of the integral of S 1 d sigma, or I say dA and d sigma, that's the same thing. Oh, you can see S 1 d sigma. Okay, as long as you don't have dx dy, so it means you integrate the surface. Okay, so the physical meaning of that is this gives us the area. The answer is this gives us the area of this surface S. Okay. The second question for the question number for the problem number 12 is for the triple integral. So let's say T be a 3D object. So it defines actually a 3D object for T. So the question is, what is the physical meaning of? It's also talk about the physical meaning of some integration of the triple integral of T and 1 over dV. So dV means is a small cube, very tiny cube. Okay, you integrate that. What does that mean? So this is the physical meaning of this integral is it gives the volume of the object T. Okay, So that's phase meaning of the surface integral and the triple integral. You can also talk about the line integral. No, not line integral, the double integral. The double integral talk about the area of the domain. Okay, that's same meaning. Okay, now let's move to the question number 13. The question number 13, so it actually talks about how to compute the line integral and also how to use the Green theorem to compute the line integral. That's what this problem is about. Okay, so the question says, let C be the line. Okay, C be the line. Let's draw it over here. So I have, this is, let me draw it over here, X and Y. So I have a line. So this is the line. Okay, this is a counterclockwise motion. So this is my C. Okay, and okay. So of course I say this here is A. This is A. So means the radius. So this one, the C is a counterclockwise circle center origin with a radius. I think is 1. Okay, I say it's a 1 or A. Okay, let's say it's A. Okay, to be a general. So my C is R sub t, represented by R sub t, which is given by A cosine t and A sine t. So t is from 0 to 2 pi. So here A is positive. This is positive. It's a constant. So which means this is defined a line. So you start as a line, start from here, from this point, because when t0, A cosine t is A, which means the x value is A and y is 0. So this is what my, it going from here counterclockwise and start and end at the same point. So that's my line. Okay, the first question is, okay, let me write over here. The first question is compute the line integral of this guy, integration for C, which is f1 dx plus f2 dy, and my f1 is negative by, so b is a constant, y is just y. Okay, f2 is bx. Okay, so here I said b is a constant. Okay, so I want to compute this. So my hint I give you is, well, this guy integrate c f1 dx dy plus dy is the same as c f vector dot dr. Okay, it's f vector is defined by f1 f2. Okay, of course my order f1 and f2 is, I can write f1 is negative by, f2 is bx. So that's my f1 f2. So in order to do this, so we can use the line integrals. In the previous, let's see, question, which question? So in the question number 10, I talk about how to compute the line integral already. So we follow the same approach. What we do is we consider the line because the only whatever value only equal along the line. So for the line is defined by this, which means this first one is x, the second one is y. So what we do is we just replace this y by a sine t, and this x by a cosine t. So it's defined by this line. And then we do here is we can compute it here. So we just have to replace. So when you do integrate over c, you just integrate, because c is defined by from t from 0 to 2 pi. Just replace from t0 to t is 2 pi. And f, I do it over here. So f is given here. I just have to replace this by y by a sine t and x by a cosine t. So here is negative b sine t, and I have to b times a cosine sine t. Okay, and b a cosine t. So that's my f vector by replacing y with a sine t, x with a cosine t. Okay, the next one is r dr. This is written by r dot and dt. Okay, now let's say replace r dot. R dot is the dot of this guy, right? Individually. So this is the dot of a cosine t dot. Okay, a is a constant, so it's negative a sine t, and a sine t derivative is a is constant, sine t derivative is cosine t, so this is a cosine t. Alright, so this is my integration. So integration, it drops this t, so 0 from 0 to t to 2 pi. So this is dot product. Okay, the dot product say, okay, it's just this guy times this guy plus this guy times this guy, right? So it's negative b a sine t times negative a sine t. So I just drops this negative times a sine t plus this is a b a cosine t times a cosine t. Okay, over dt. Okay, this is 0 to 2 pi, and this we just say this is a square b sine t squared. This is a square b cosine t squared. Okay, very nice. So I can just pull this out, put it together. So the plus cosine t squared and dt, because this guy is just equal to 1. So this is 0 to 2 pi a squared b and over dt. The integration of this is always this is a constant. It's not a function of t. So this integration gives us a squared b times t e back to 0 to 2 pi. So which is a squared b times 2 pi minus 0, because there's nothing minus 0, so I can ignore that. So this is just the value is just equal to a squared b times 2 pi, just 2 pi a squared b. Looks a little bit nice. So that's how we compute the line integral directly. The second part of this question is to compute the line integral using Green theorem. Okay, so hey, I use Green theorem. Say recompute the line integral using Green theorem. As I mentioned before, the Green theorem will write the line integral into the double integration, or vice versa, like write in the double into line integral. Since here we're talking about line integral, so we basically write line integral into double integrations. According to Green theorem, so this is cf1 dx plus f2 dy is equal to the integration over, this is the radius, this is the region, okay, I define the region later on, partial f2 over partial x minus partial f1 over partial y and dx dy. So the region is the area, because this r is determined by what's inside, surrounded by this area. Okay, and following if we move the direction along this the circle, the line, this area is to my left. Okay, which means this is exactly inside the unit circle, inside the circle centered origin and r. So right over here says, okay, my r is centered. Let's write over here. I is centered at origin with radius a. So that's my r. Okay, if we write this way, okay, let's see what is f2. So f2 is bx, f1 is negative by. So it is integration over r partial bx. So f2 right here is bx, f1 is negative by. So partial f2 over partial x b is a constant, so which is b. Negative f1 over partial f1 over partial y, because this is f1. F1 is negative by over partial y. B is a constant, so this is negative b. Because it's a negative sign, it's negative b is a plus b dx dy. So this one is 2b, right? Integration over r 2b dx dy. Of course, this one I can put it, this constant I can put it outside. Give us 2b integration over r. This is become 1 dot dx dy. Okay, this we use the problem I mentioned here. The physical meaning of the double integration. Okay, double integration is just which is 2b times area of b of r. So that's the physical meaning of these integrations. Okay, the area I said is centered origin with radius r. So the area is pi a squared. That's my area, right? The radius is a, and the area is of the area this r is just pi a squared. So if you put together, it's 2 pi a squared b. So this one should be the same as this one, so they are equal, so which means that's great. So we can use a Green theorem. So Green theorem can simplify the computation, especially when the partial f2 over partial x minus partial f1 over partial y, this turns out to be a constant, or very simplified version, so this becomes very simple to compute. Okay, so this is question number 13. So now let's move to the last part, which is about the Fourier series. Okay, that's 3 questions. Okay, starting from question 14. Question 14 asks about the property for the functions, meaning that I want to check the function is even, odd, or neither. Okay, so check if the following functions are even, odd, or neither. Okay, the first function is sine x squared plus 1. Okay, now the second one, let's just write down everything here, is sine x squared. Okay, c is cosine x plus 1, and the d is sine x cosine squared x. Right, okay. Alright, so let's just use definition. So definition, the even odd function is given by this. So this is the definition of the even odd function. So fx, if it's even, okay, if and only if f negative x is fx. Okay, if it's odd, if and only if f negative x is negative fx. So that's the definition of the even odd function. Now we just have to check this, pull this negative sign to see what's going to happen. Okay, so let's start with the first one, a. Let's do a. Okay, sine. Good. Let's say fx is sine x squared plus 1. Okay, let's do f negative x. We just replace x, every x by its negative x. Okay, it's sine negative x squared plus 1. Okay, because sine x squared is sine negative x is the same as sine x squared plus 1, right? It's the same value. So negative squared is and positive squared is the same. So if you look at this one, they're the same, right? So which means equal to fx. So according to the definition, yeah, it is the even function. Okay, let's start with b. b again, let's say fx is sine x squared. Okay, so we do the same thing, f negative x, which is, I replace x by a negative sign. There's the sine negative x squared. Sine x is negative sine x squared. Negative doesn't really matter. Sine x squared. Okay, if we check this one, yeah, they're the same. It's the same as sine x squared, so which is the same. So it is fx. Yes, this is the even function. Okay, let's go to the c part. c is cosine x plus 1. Let's see, fx is cosine x plus 1. Let's again do f negative x is cosine negative x plus 1. Now how can we do with this one? Now this one, because I only care about relationship between, is this one equal to fx? Because fx is cosine x plus 1. Yeah, it doesn't, so you can say here this is not equal. Okay. Then we're gonna check next one. Is this one equal to fx equal to f negative x? Sorry, it's negative fx, which is negative cosine x plus 1, right? Okay. This one also is not equal to this because that's not a relationship. So yeah, that's why it's not. It's neither. But over here, this is neither. Okay. So now goes the last one. Okay, which is sine x. We do this. Fx is sine x cosine x squared. Okay, so f negative x, okay, is sine, we change fx to be negative 1 cosine negative x squared, basically, right? So sine negative x is negative sine x, cosine negative x is cosine x, so it's cosine x squared. Okay, if we look at this one will be the same as fx, so this is a negative fx. Okay, So this one is odd function, right? Because this one equal to negative that. You can also check from last one, at least you can do here is, because sine x is odd, cosine x squared is even, right? So odd times even is odd. So that's a property for the even odd function you can use, okay? But you can always use it. This is the original definition that we can always use this. Okay, now let's move to the question number 15. The question number 15 talks about define a periodic function. So, okay, a periodic function f(x), which is given by 2 plus x, 5 minus x. Okay, this is x is less equal to -3 is like less than 0, and x is greater than 0, -3. So that's my, and also say fx is equal to fx plus 6, so which means it is a periodic function because this one defines, this is for x, defines a, even talk about a period. The period is the fundamental period is 6 because it will repeat every 6 unit. Okay, so this one says, the question says, let the Fourier series of x is given by gx. Okay, it's Fourier series of fx is given by gx, which is given by a0 plus summation n from 1 to infinity. This one is an cosine n pi over 3x plus bn and sine n pi over 3x. So that's my Fourier series, right? Okay, so my question is compute the value of G3. Okay, so the hint I give you is discontinuous. So typically, so this G of, typically, because this is a force, so typically gx should be equal to fx, okay, unless at any point, at every point, if this point, if fx at this point is continuous, which means there's no jump at this point. It means the limit of on the left side and limit on the right side that's the same. That's called this it's continuous. If that's the case, your gx is just equal to fx. You just have to replace everything back to fx. Your gx is whatever value. Let's say gx x equal to 2, for example, which is fx equal to x equal to 2, because if you do it here at 2, it's a continuous. When x is 2, sorry, it's bottom one. X is 2 is defined by 5 minus 2 is 3, basically, right? This is a continuous because this is defined as continuous function, right? Well, we want to look at the G3 now. If G at this continuous point is my Gx, so that's the next property, is Gx equal to f. Let's see, let's write it here. Gx0 is limit x to x0 plus fx plus limit x to x0 minus divided by 2, which means that we compute the limit from left hand side and limit to the right hand side to compute the value. Okay, so that's we have this is average 2 if fx at x equal to x0 is discontinuous. Now this case for the when x equal to 3, this is discontinuous. So if it applies to the second case applies because it's discontinuous. Okay, so which means hey, my G3 is just be given. In other words, if that's the case, my G sub 3 is just equal to limit x goes to 3 plus fx plus limit x goes to 3 minus fx equal divided by 2. Okay, let's go to limit. So limit 1 when it goes to x goes to approach 3 plus, it means you're going to approach this one from the plus side. Okay. Of course, this gonna be a little bit challenging because what is this side? Okay, because this one, if you do this one, it's a little bit. So I know it's 3 minus because it's gonna this one you know how to compute this because it's moved from. If I draw the fx, I draw the fx a little bit. Let's see what's gonna happen. Okay. So which means the -3. So if this is okay, if I'm going to this is -3. Okay, this is part of 3. So this one, if it's from -3 to +1, right? So this one is defined. So this one is easy to compute, right? If you do x from 0 to 3, it's 5 over x, which means it's 0. This is 5. This is 5 value 5 minus x, and 3 to become 2, right? So it's something like this. Okay, so that's what defined over here, and this is 2 plus x is -3. So this is -3 from here. This is what's defined. So which means when x is 0, this is 2. So 2 over here, and I got 2 plus. So which means somehow like this. Okay, which is when x is equal to -3 is -1. So it's something like this. Is somehow over here. Let's draw -3 over here. So this is somehow this. Okay, so that's discontinuous because fundamental period is according to here. Once I have this one, so once it go to 3 to 6, let's do here. This is 3. This is 2. This is 6. So this one you repeat the same pattern. You basically have something over here. You shift it over here. So okay, I'm going to somehow like this. So this is the same pattern as over here. That's why, okay, when you look at the 3, okay, when you have this one, okay, let's talk about what this means. This means you're going to 3 minus means you're going to from minus side because you're starting from less than 3. You're going to gradually approach this 3. Okay, so that's why this second one is given by this. Let's forget about leave the first one. So this one given because this is given by function 1. This is given by 5 minus x. This line is given by x. This because this is a higher draw it. But this is a 5 minus x. So this is given by. Okay, let's see. I put over here this 2. This is the limit x goes to 3 minus, and this is 5 minus x. So that's how I draw this line. Now this line is given by what? It's given by 2 plus x. Okay, of course this is also 2 plus x. That's the no, this is not 2 plus x. So this guy is 2 plus x. This one when you shift over here, it doesn't change, which means hey, I'm going to have this value. So this value when you this guy is a limit. So when you do this one, okay, let's draw a little bit careful. When you do right over here, when you do this limit, so limit you to say, hey, I'm gonna approach this guy because this guy physics means you're gonna approach this from this side. Okay, you're gonna when x has to be positive, and you're gonna make it positive. You start from some point and make it small until you reach it very close. Essentially, you stop at 3. That's what this one means. Now this value here, because you essentially, if I look at it over here, this is defined by this, so eventually you're gonna reach this point, right? Use blue, which is this point. Now this point of this value is the same as this value, right? If we look at this one, right? So the limit of this guy is the same of limit x goes to -3 plus, and fx here is given by this 2 plus x. Okay, and okay, let's draw this 2 from the previous line. So this is basically what is we give by this. Okay, I'm gonna do. Let's draw this. I just move this one here. If fx is discontinuous at x equal to x0, Okay, I'm going to pull this one. Let's rewrite this. So this one is equal to limit x goes to -3 plus fx plus limit x goes to 3 minus, I have to replace fx by 2 plus x. This is given by 5 minus x. Okay, so the reason, okay, this one is very easy to understand because it defined 5 minus x over here, and I let x approaches an x minus 3 because it's from 3 minus side, so it's always defined by this function, right, until I reach very close to 3. Now this first one is I'm going to compute fx when x approaches 3 from the positive side, which means I'm going to have some plus more than 3x as a starting point. I'm going to approach this 3 from the positive side. Now this function is not, I don't know, we have to figure out this function, but we don't have to compute it because this one, the limit of this value is the same as, because it's periodic, so it's the same as I'm going to approach this one from this side, okay, to -3, okay, that's why I do this way, okay. So in this way I don't have to find the function for this one, okay. So that's why I have computed, this is the same as this guy, this is the same as this guy, so I have computed that. So now we can replace the number because this one is the same as, you replace x by -3, so it's 2 plus -3 plus, this is 5 minus 3, right? Because actually you can do this one is 5 plus 3 minus, because -3 minus is very, very close, it's essentially is -3, and this is part of 3, okay, divided by 2. So this is -1 plus, so this is 2 minus 3 is -1 plus 5 minus is 2 divided by 2. So it's essentially given that by half. So a common mistake over here is you might want to do this. Don't do this. If I want to do this, don't do this directly. It's equal to limit 2 plus x, and the limit x goes to this is x goes to 3 plus. This is not okay. This is not right. Okay, the reason is, if I would draw this 2 minus plus x this way, now you define this one is solely doing this. You're doing this because this has to be a continuation of this over here. Now apparently this is not as repeated. If you do this, not repeated. You have to shift this one. If you don't want to do this, you actually compute this point. You're not computing this point. So that's why this one, because this one is equal to this one, you're gonna have the same periodic function. That's why don't do this. This is not right. Okay, and this is correct. Okay, just be a little bit careful. Okay, so this is question number 15. Now we're going to the last question. Okay, I probably put a little bit wrong label number over here, so it has to be question number 16. Okay, I label it as question number 17 probably. Okay, it says fx to be cosine 2x plus sine x, so with its fundamental period of 2 pi and its Fourier series being given by a0 plus, as due to the fx given by a0 plus summation n from 1 to infinity an cosine n x plus bn sine nx. So, okay, so the problem here is compute an bn. So should be here n is from 0 1 infinity, and bn n from 1 to infinity. Okay, you basically find the coefficient for the periodic function. Okay, all right. So we just use the definition. The definition says, this is what definition says. So A0, here's how we compute that. So A0 is integration of 1 over 2 pi, integration of negative pi to pi, fx dx. Okay, so which is negative 2 pi, integration negative pi to pi. This is the cosine 2x plus sine x dx. Okay, so integration of this guy is, so to keep this over here, the integration of cosine 2x is 1/2 sine 2x, and this is a cosine x integration negative cosine x divided by pi, negative pi. Okay, so this is negative 2 pi, so this is sine 2 pi is 0, 1/2 sine 2, this is 0, minus cosine pi. Cosine pi is 0, let's see, 1, negative 1, but it's a negative 1, it's positive 1, okay? And when this is negative pi, it's 1/2 sine 2, negative 2 pi, sine negative pi is also 0, okay? This is minus cosine negative pi, cosine pi is negative 1, so it's minus 1, minus 1, so it's a minus 1 equal to 0. Okay, 0. Okay, that's A0, and AN is 1 over negative pi, integration of negative pi fx. This is cosine nx dx. Okay, so this one equal to 1 over pi, negative pi and the pi. Fx right over here is cosine 2x sine x cosine nx dx. Okay, this one can recognize 1 over pi, negative pi to pi, cosine 2x cosine nx dx. Let's just do the product and separate them, plus negative pi to pi sine x cosine nx as to dx. Okay, this one we use the orthogonality property. So this is orthogonality property, because sine x times cosine nx, doesn't matter what x we anyway have, so the integration of that one is always equal to 0. And this one we also say it's an orthogonality property. This one, so this one is, so this one I can write this as is pi over 2. It can include two parts, so it's 1 pi over 2 is pi over 1 over pi, negative pi times cosine 2x cosine 2x. This one is not 0. If it's not equal to n is not equal to 2, is also orthogonality property. So this is 0 if n is not equal to 2. Okay, if this is n is equal to 2, it's just given by this. Okay, let's just have to calculate this one. So this is given by, let's calculate the integration. Okay, so negative 1 over pi, negative pi. So cosine x squared, is, let's use the property, is we have to use the trigonometric property over here. It's this is cosine 2x squared over dx. Okay, so this one is equal to, I use the trigonometric property, it's 1 over pi, negative pi. This is 1 plus cosine 4x divided by 2 dx. That's the property that I used. Okay, negative pi over pi. So this is the integral. This guy is 1/2. So this one can be written as 1/2 plus 1/2 of that. So 1/2 over dx, it will be just 1/2 x plus this is a sine 4x. Okay, this is cosine sine 4x divided by 8 over dx. Oh no, divided as negative pi to pi. Okay, so this is a negative pi. This is a 1/2 pi. Okay, and this guy is 0 because sine 4 pi is 0. Okay, so this is, and then minus 1/2 negative pi. Okay, sine 4 negative 4 is also 0, so I can ignore that. So this becomes 1 over pi. This is half pi plus half pi, which is pi, which is 1. Okay, so which means this is equal to 1 if it's n equal to 2 and the 0 is n equal to -2. So this is how we compute the an. The last part is one compute bn. Okay, this is bn. Let's compute bn. Bn is 1 over pi, negative pi pi. This is fx times sine nx dx, which is integration 1 over pi, negative pi pi fx. I should replace fx by cosine 2x plus sine x sine nx dx. Okay, which is, let's write it here, that's equal to 1 over pi integration negative pi pi. I just do the product and separate them. Cosine 2x sine nx dx plus negative pi into pi. This is sine x sine nx dx. Okay. Again, as I mentioned before, this is a orthogonality property. So this one be 0, and this guy is basically essentially is given by this. Okay, it is 1 over pi negative pi over pi sine x and sine nx dx. Okay, so this one again, our orthogonality property, this can be written as if n is not equal to 1, because it sine other values also orthogonality, so it's also 0. So only values that was non-zero is this, negative pi to pi. When n is equal to 1, which means here is sine x times sine x, and it's 1, okay, sine x squared dx. Okay, we can compute the value here is negative pi, 1 over pi, negative pi over pi, sine x squared is 1 minus sine 2x, 1 over, I think 1 should be there, hold on. This one is equal to 1 over cosine 2x divided by 2. So okay, this can be 1 over 2 minus cosine 2x divided by 2 over dx. So integrate that part is 1 over pi over pi. The integration of this one will be 1/2 pi. This is minus sine 2x over 4 divided by negative pi and pi, which is negative pi. This is x, sorry. So this is 1/2 pi, and minus this is sine 2 pi 0, okay, and minus 1/2 negative pi. Sine negative 2 pi over 4, this is also 0, so I can ignore that. So this one, if we keep on doing, this one give us negative pi over time. This is just 1/2 pi plus, because minus cancel out, so 1/2 pi plus 1/2 pi, which is pi to 0. So which means this one equal to 1 if n equal to 1 and 0 if n is not equal to 1. Okay, so that concludes the final exam review.